Hello and welcome. What we're going to do here today is go through writing formulas part 3. This is part of a series. And what we'll be doing in this video is constructing binary ionic compounds, where binary means two, okay, bi, two. Ionic meaning ionic is going to be composed of two charged particles, one metal and one nonmetal. And then we'll be building some compounds here, constructing binary ionic compounds. So what specifically is a binary ionic compound? Well, a binary ionic compound is composed of, like I said, one metal and one nonmetal. That means one element, the first element, will always be on the left of the stair step, and the other element will be on the right-hand side of the stair step. So one metal and one nonmetal. The net charge of our compound will always be 0, so the charges will need to cancel out. We'll use the least common multiple method and we'll shorten it by crisscrossing charges. In naming, we'll apply the suffix IDE to the end of the second element in the compound, so that would be the nonmetal. And then remember, as we name, we will also incorporate Roman numerals as needed. And the place where we'll need our Roman numerals is here in the center of our periodic table, our group B elements, or are also known as our transition elements, as well as tin and lead. And the reason, because these guys have multiple oxidation states. They have multiple charges, so the only way we know what kind of charge they form is by telling it to us in the form of a Roman numeral. Remember, group 1A elements form a +1 charge, group 2A elements typically form a +2 charge, 3A plus 3, 5A minus 3, 6A minus 2, and 7A minus 1. And the reason for those charges is due to their proximity of the proximity to the noble gases. All right, so let's start taking a look at a couple of examples. All right, what we've got here for you today is 3 quick examples. The first example, we want to construct a compound using sodium and oxygen. The first step in doing so is identifying and locating those elements on the periodic table. Here we have sodium in group 1A, indicating that we'll form a +1 charge with our sodium atom. And oxygen will form a -2 charge because it is 2 elements away, 2 electrons away from achieving noble gas notation. All right, it's got to gain 2 electrons, forming that -2 charge. So let's get to work. First of all, first thing I will do is I'll write down the symbol of that element along with its charge. So sodium symbol is Na, and its charge is +1. So I'll just write plus. And then oxygen over here forms a -2 charge. Okay, so I'm going to write the symbol O with a -2 charge. Now, to write a formula, there's 2 ways. What we can do first is use least common multiples to identify the charge. All right, the least common multiple, LCM, where what's the least common multiple between 1 and 2? It's 2. What times 1 gives you 2? 2 times 1 gives you 2. And what times 2 gives you 2? 2 times 1 gives you 2. The least common multiple is 2 here. The other trick would be to crisscross. Take the charge and crisscross it down. My arrow's a little messed up, but that's okay. You can see the subscripts would be 2 and 1 for sodium and oxygen, respectively. So let's go ahead and rewrite my final answer for the formula, nice and pretty. The formula here would be Na2O. Now, the way that I would say this compound and give its name is I would give it the name sodium, because the metal will always retain its name, and then oxide, because oxygen will replace that suffix, the ending of oxygen, with the suffix IDE. So that suffix got inserted into the compound name. Sodium and oxygen forms sodium oxide, Na2O. Next, let's take a look at this compound, chromium and sulfur. Well, chromium is Cr in the center of the periodic table. Sulfur is over here forming a -2 charge. So I'm going to go ahead and start writing it. Cr. We don't know the charge of chromium because it's a transition element. So I'm going to give it to you here in a second. And then sulfur forms a -2 charge. So again, it's in the -2 column. Well, chromium in this case is going to be chromium 3. All right, it's going to be chromium 3. So it will have a 3+ charge. Now this charge will have to be given to you somehow, some way, because chromium again forms multiple oxidation states, forms multiple charges. So the person that's assessing you would have to give you this much information. All right. Now let's try to write the formula. Again, the least common multiple is a method that you can use to identify the formula. What's the least common multiple between 3 and 2? That's right, it's 6. Where 3 times 2 is 6 and 2 times 3 is 6. Now, of course, we could use the crisscross method as well and crisscross those charges down, or the absolute values of those charges down, to identify the formulas. To write the formula nice and clean, I'd write Cr2S3. And this would be the formula for this compound containing chromium 3 and sulfur. To write its name, I'd write the metal's name first, chromium. Now recall, chromium is a transition element. Transition elements, tin and lead, all need a Roman numeral after that metal's name. And that Roman numeral that will go here is going to identify the charge of chromium, in this case 3. So I write the Roman numeral of 3. And remember, this is indicating its charge. And then sulfur, just like oxygen turned into oxide, sulfur will turn into sulfide. We're replacing the suffix, the ending of sulfur, this UR, with the suffix IDE. All right, our final example for this morning, aluminum and nitrogen. Let's figure out what kind of compound will form between aluminum and nitrogen. We'll locate the two elements on the periodic table. Aluminum is here, nitrogen is here. Aluminum is in group 3A, forming a +3 charge. Nitrogen is in group 5A, forming a -3 charge. So let's go ahead and start working on it. Aluminum, again, forming that +3 charge. Nitrogen, forming that -3 charge. To write a formula, we can use the least common multiple method, the LCM, least common multiple. And the least common multiple between 3 and 3 is 3, of course, where 3 times 1 gives you 3 and 3 times 1 gives you 3. Now, this is the case where the crisscross method is slightly insufficient. As you can see, if we crisscross the absolute value of these charges down, we'd have a 3 and a 3. All right, we'd have 3 aluminums as well as 3 nitrogens. Well, those 3's could kind of like cancel out, and you'd be left with 1's, and 1 is the actual correct answer. That's what we're looking for. So the formula for aluminum and nitrogen, when they combine, it would be AlN. Pretty simple and straightforward. And the name here would be aluminum. Aluminum. Remember, aluminum is not a transition element, so there's no need for a Roman numeral. And now it's nitrogen, so instead of nitrogen, we'll write nitride. All right, nitride, because we're replacing that suffix with the suffix IDE. All right, so as far as naming is concerned, recall we've got the suffix IDE on the end of each non-metal, and we have a Roman numeral indicating the charge, the +3 charge of our transition elements tin or lead. All right. Recall, to wrap this up, binary ionic compounds form between a metal and a nonmetal, where the net charge of the compound is always 0. We can find that using the least common multiple or the crisscross method. The suffix of the second element, the nonmetal, will always contain IDE. And remember, you always need to use Roman numerals. This is one of the most common mistakes or omissions by students in chemistry classes. All right, hopefully that was clear, and I look forward to success. All right, I hope you look forward to success in writing formulas. Thank you.